We can also look at calculating the intercepts of quadratic functions. For any function, the x-intercepts will occur at all points of the form x, 0, meaning we have some non-zero coordinate for x, and our y value is equal to 0. Similarly, our y-intercepts will all be of the form 0, y, meaning our x value is 0, and then we have some non-zero value for y. That means to find an intercept, what we need to do is set the opposite variable equal to 0, and then solve for the remaining variable. In example 5, we have the function s of x equals x squared plus 5x plus 4. To find the x-intercept, we'll set our y variable equal to 0. And then solve this quadratic equation. We can do that using the quadratic formula, or we can factor. In this case, this would factor as x plus 4 times x plus 1. That gives us two equations to solve. X plus 4 is equal to 0, and x plus 1 is equal to 0. Meaning we have two solutions, x is equal to -4 and x is equal to -1. Translating those into coordinate form, we have an intercept at the point -4, 0, and one at the point -1, 0. To find y-intercepts, we set x equal to 0. That's the same thing as evaluating s of 0. When we do that, we'll get 0 squared plus 5 times 0, which will just be 0, plus 4. So we get a y coordinate of 4, meaning our y-intercept occurs at the point 0, 4. Similarly, in example 6, we find our x-intercept by setting the y variable or the function variable equal to 0. And then we can use the quadratic formula, or we can again factor to solve this. We can start off by factoring out the greatest coefficient of -3, leaving us with x squared minus x minus 12, which would then factor as -3 times x minus 4 times x plus 3. This gives us three different equations to solve by taking each of those factors set equal to 0. We don't really need those parentheses around those factors, but I did include them there. So we would look at each of these equations and find the solutions. -3 is never equal to 0, so that first factor doesn't yield any solutions. Adding 4 to both sides would give us x equals 4 as a solution, and then subtracting 3 would give us x equals -3 as a solution. So we end up with x-intercepts at 4, 0 and -3, 0. To find the y-intercept, again, we'll evaluate our given function at 0, meaning we'll find r of 0 in this case. Our first term will go to 0 when we plug in x equals 0. Our second term goes to 0, leaving us with just 36. So our y-intercept occurs at the point 0, 36.